Hello Year 10 and welcome to the next lesson on sectors, where we're looking at finding the area of a sector, which we now understand to be a part of a circle, and also looking at finding the angle. So if you could rule off where we got to last lesson, write the date and the title, please pause the video as you do this. Good, well done. You can be able to see that the success criteria for today is bronze to be able to calculate the area of a sector, silver to be able to calculate the angle of a sector, and gold is to be able to answer some problem-solving examination type questions. Right, here is the formula that we would use to find the area of a sector, and again, this is a formula, this part in particular, that you'll be familiar with because we know that pi multiplied by radius squared is how you find the area of an entire circle. But we don't want the area of the entire circle, we just want the area of part of the circle, of this particular sector, of this proportion, and that's again why we have this part of the formula that includes theta over 360, which is the angle given out of 360, which is the total degrees around a point. If you could quickly just write this formula down in your exercise book and then pause the video as you do this. Right, well done. If you can make sure you have your calculator ready with you today as well. We're going to go through an example here. The same circle actually we looked at yesterday to find the arc length, but this time we're finding the area. So we'll just go through the example together and then you can pause the video as you copy it down and take some notes. So first things first, that's our formula. What we will next do is substitute in any values we know into the formula. Well, we know what theta is, it's 30, and we know the radius is 18. So we can put that in here. We're doing 30 over 360 multiplied by pi multiplied by 18 squared. Make sure you remember to put the squared into your calculator. You're looking for the button that has an X and a squared sign, and that will do it for you. Then just to break it down like last lesson, we know 30 over 360 is a 12th, and we know that 18 squared is 324. Now we know that your calculator will do all of this for you, but it's always worth looking at the breakdown of information if you get questions that are non-calculator based. We know that a 12th of 324 means you do 324 divided by 12 and you get 27. And then 27 pi as an answer to two decimal places will be 84.82 centimetres squared. If you could please just input this information, the formula, into your calculators to check that you get the right answer, and then pause the video as you copy down the worked example. Right, good, well done. We're going to look at a practice question together, but I would like you to have a go first at finding the area of the sector, and the sector is this peach coloured sector here, not the larger one, it's the minor sector. Just pause the video please as you do this. Right, good, well done. If we've substituted the values in first, always show that element of working out even in a calculator question. We should have 100 over 360 because there is 100. And then our area is times pi times 6 squared because that's our radius. And then you should have got 31.4 centimetres squared. Remember, it's to one decimal place because that's what the answer asks us to give in. Right, brilliant. If you could please calculate the area of each of these sectors below. And here we want the answer to two decimal places, so just be careful with your rounding. You don't need to draw the sectors out, just show you're working clearly. So the formula, the substituted numbers, and then your answer to two decimal places. Please pause the video as you do this. Right, good, well done. So for the first one, you should have 47.52 centimetres squared. 463.60 millimetres squared, so it's to two decimal places, so we have to include that 0, and notice it's millimetres this time. Then it's 589.05 centimetres squared, it's 982.97 centimetres squared, it's 3,959.72 millimetres squared, and then it's 36.93 centimetres squared. Right, please have a look at this examination question, have a go at it, and pause the video whilst you do this. Right, good, we'll have a look at how it works. So it says, the beam, which is the light from a lighthouse, reaches a distance of 8 kilometres and spreads to an angle of 35 degrees. Calculate the area covered by the beam from the lighthouse. So we've got a context here, but actually, it would be the same as if you were given this diagram and asked to find the area. So again, like last lesson, draw it out if it helps you. We know how to find the area of a sector. It's theta, so our angle over 360, times pi times radius squared, and you should have got 19.55 kilometres squared if you've done it to two decimal places. It might be slightly different if you've done it to one, but just check your rounding carefully. Right, we're going to have a look at quite a complex question here. And what I would like you to do first is, before we go through the step-by-step process of how you do this question, is just to pause the video and maybe start to jot down how you think you will answer this question. Are there things you can do? Now, what I will do is read it. So it says the arc ABC, which we know how to find, is a quarter of a circle with centre 0. So we know we're working with a sector. We don't know the arc yet. We know that this sector has a radius of 4.8 centimetres. And then you're told AC is a chord of the circle, and that's a word we've seen before as well. It's a line that runs from one part of the circumference to another, but not through the middle of the circle. Work out the area of the shaded segment, and that's our shaded segment, the part in grey. So are there things you can do to pick up points and pick up marks along the way? Please pause the video as you have a read and have a go. Right, good. What you should have done first and foremost is to find the area of the triangle, or find the area of the sector. So if we start here, we'll find the area of the sector, which we know how to do, okay? We know that to do that, we do our theta around 90, and we're told it's 90 because we have our right angle box here, over 360 times pi times 4.8 squared, because that's the formula to find the area of a whole sector. So if we calculate that on our calculator, and if you've not, you can do it now, we get the whole area, the orange triangle and the sector. But we don't want the whole area, we want just this bit. So we have to subtract from the area of the sector the area of the triangle. And we know how to find the area of a triangle. It's base times height divided by 2. So you would subtract that answer from the total area of the sector, and you should get to 3 significant figures, 6.58 centimetres squared. But again, if you're not sure about rounding to significant figures still, okay, and there are things you can look at on Heggerty to help you, you know how to find the area of a triangle, and you know how to find the area of a sector because we've looked at it today. So you should be able to do lots of elements. And if you can do that, you can do a simple subtraction in your calculator to get the answer. Right, last thing, we're going to look at finding the angle of a sector when given the radius and the arc. So this time, what we're looking for is this missing angle. So when we talk about working backwards and doing the inverse when we looked at linear equations, that comes in handy here, because that's what we're trying to find. And we're given the radius of 8.5 and we're given the arc of 12. So we need to rearrange this formula to make theta, which is the angle, the subject. Now, in order to do that, we have to get rid of a divide by 360. And we know that the inverse of dividing is to multiply. So we multiply by 360 on this side. We know that to get rid of a multiply by 2 times pi r squared, you have to divide. So if you rearrange the formula, look, to get rid of a divide by 360, we times, and to get rid of a times by 2 pi r, we divide. So you're just looking at changing the subject of the formula by using inverse operations, which we've looked at a lot before. And now that we've got this formula for finding the angle, we can now substitute in what we know. So if you could just follow this example and then copy it down at the end. We know the arc length is 12 because we're told on the diagram, and we know the radius is 8.5. So we can substitute those values in, and when we're using our calculator, we can press the fraction button and put all of this information in together. If we break it down, 12 times 360 is 4,230, and then 2 times 8.5 is 17, so our denominator is pi 17. But if we want to work out our full answer to one decimal place, we would get 80.9. Please pause the video as you copy down the formula and the example. Brilliant. Right, if you could now have a go at this other example question on your own. So it says calculate the angle at the centre of this sector. Just to be clear, that 9 does just signify the radius. Okay, so that's ready for you. And we're trying to find the angle to one decimal place. Please pause the video as you have a go and just use the formula that you wrote down from the previous slide. Right, very good. Let's have a look what we should have got. So there is our formula again. Our arc length is 25, we can see that on the diagram, and we can see our radius is 9. We can then show that 25 times 360, if we choose to, is 9,000, and 2 times 9 is 18, so the bottom of our fraction is 18 pi, or pi 18. We can then find the actual answer to one decimal place, which is 159.1 decimal. to 1 decimal place. So that's 159.1 degrees. Right, I would like you to have a go at another practice question for me and pause the video as you do this. Right, very well done. So first things first is we're using our formula. We've got the arc length here, which is 42. We're trying to find the angle. We have our radius of 13. So we can substitute those into our formula here and we end up with this. Okay, if we then show the breakdown of how we get from our formula to our answer, we can see as a numerator we have 15,120 and as a denominator we have pi 26, and it should be clear that those two values come from these two calculations. Our answer to 1 decimal place is then 185.1 degrees to 1 decimal place. Now you don't need to worry that it doesn't necessarily look like 185.1 degrees. Remember, pictures aren't always drawn accurately. If you've done the calculation correctly, your answer will be right. Lovely. If you could have a go at these 4 questions, just be careful with D because it's a worded question. If it helps, you can draw out the diagram to support you. But please pause the video as you answer these questions. Look, you need to write your answers to 1 decimal place and then we'll go through the answers together. Well done. So for A, you should have 28.6 degrees. For C, sorry, it's in a funny order. For C, 54.9 degrees. For B, 66.8 degrees. And for D, 91.7 degrees. Here is a GCSE exam questions. This is very higher tier based on the foundation level work. It's a level 5 question. You may choose to have a go at this question as an additional challenge. You don't have to. But if you read through the problem carefully, there are some tips here to help you. And we have looked at some questions like this before when we were looking at area of a circle. So just think back to that. And then what I would like you to do is complete the relevant Hegarty tasks as set out on the guidance sheet, but just for your information, here they are 5, 4, 6 and 5, 4, 7 to support your knowledge and understanding. Very well done. If you have any questions about anything we've done in these 2 lessons or the Hegarty tasks, please get in touch with your classroom teacher. Well done.